Hello, good morning. It's Mr. Snow again. We're going to be going over freeCodeCamp.com's basic algorithm scripting challenges, and today we're doing Caesars Cipher. It's my favorite one. It's got lots of stuff involved, and it requires us to look at more than just one or two things. So there's a lot of things that we need to be understanding in order to complete this challenge. So I've got a bunch of tabs open for you, and a lot of things I want to explain and go over with you. So I'm going to jump right in and share my screen and start by going over the challenge itself, which is Caesars Cipher Challenge. All right. Now it says one of the most widely known and simplest ciphers is Caesar's cipher, known as a shift cipher. In a shift cipher, the meanings of the letters are shifted by some set amount. A modern use is the ROT13 cipher. Oh, look, there's a link. So what does the ROT13 cipher mean? Well, take a look up here. Essentially, we take our 26 letters, we divide them in half, and we put them alongside of each other, and we switch their places. So an A becomes an N becomes an A, all right, so on and so forth. So how are we going to get this done? We're given a few more clues here. We're looking at string methods known as charcode at and from charcode. All right, so that's good. So here is from charcode. So what does from charcode do? Well, your syntax is string dot from charcode, and what you can do is you can actually place in a value here, a number. It would be a parameter, and then you will get a character from that specific character code or chart code. So 65, 66, 67 will return capital A, B, C. All right, so how's it getting that from these numbers? Well, that's actually the ASCII decimal values. How did I find this out? Well, my good friend Google and some searching around, and I found this is where it came from. So here is capital A, and here's the decimal 65. And it just so happens that is where we get this from. Good, so we're matching up. We know where these letters and numbers come from. In our challenge, in order to pass our challenge, it looks like we're only dealing with capital letters. Okay, so we have a cipher with only capital letters that we have to worry about from our ASCII table. So what we need to do is we need to be able to isolate the letters A here through M, and then isolate the letters, capital letters N through Z. All right, well, do we have corresponding chart codes or decimal ASCII codes for that? Yes, we do. We have the numbers 65 for capital A. Let's go down to M. That takes us to 77. And then we go from 78 all the way down to capital Z, which is 90. All right, so that's going to be important for how we're going to solve this. So we know that we are going to be given a string, and from that string, we need to do some things. And then what we need to do is we need to return a string. So we're going to be transforming this into an array and then doing something with it. And then we need to spit back out a string. So we're going to go from string to array to string. So we can just say that our argument str that needs to go into our function here, ROT13, needs to equal our str. And if you remember how we go from a string to an array, just like we've done multiple times before, is we're going to use split. Okay, we're going to split that by an empty string, which is going to give us every single object in there, letter, space, gap. All right, then we need to do something to that array, which is going to be some method. And I'm going to be using map here. And map allows us to add a function, or to do a function to every object in that array, right? And then we have to join that back together by the same thing, our empty string, and we're going to get back what we want, okay? And then at the end, we can just return our string. All right, so here's our function here. Now, what exactly are we doing with this map? And we haven't used this before. All right, so what does that mean? Well, that means we have to actually figure out what's going on. And if you notice, function I have here is an anonymous function, and we're not actually going to use an anonymous function, which is why we have all these errors. Before I even get into how to use map, let's go back and take a look at for each. Now, previously we've used for each and for loops to iterate through an array. So how come this time I'm using map? Well, I was kind of taking a look at different solutions and which ones are sort of the easiest or the best way to kind of go through. And notice, remember, for each will allow us to apply a function to everything in an array as well. So here I found a little quick explanation that seems to work pretty good as to why you would use map as opposed to for each. So in this example, we're taking a simple array, okay, and then we're applying this dot map function to it. And then right at the end, we can chain, okay, a sort method, let's say, or we can chain another method. In this case, we're going to actually chain that join method to it to put this back together. What this allows us to do is in our code to give us one simple line of code for our main logic. Okay, this is going to be more important as we move on writing more complex programs later on. So the logic of our main function here just splits, applies a function, joins, and then returns that value. That's it. And we can define this function here. Instead of this being an anonymous function, we can use a function that we define later. All right. And I can just call this Caesar. All right, for Caesars Cipher. All right, so that's going to be our Caesars Cipher function, which means that somewhere, all right, either above or below this main logic here, we're going to have to define our function that we're calling. So we called Caesar, and we know that that needs to be a function. So here's my function Caesar, and I know I need to take in some argument, and I'm going to make this a function. Okay. And what do we want to take into this? Okay. Well, if we're going to be splitting and then add this map, what exactly is the map doing? All right, so here is prototype map, and this is why I like this. So again, we're doing this so we can chain everything for our logic and break out our function instead of nesting our functions to make it easier to read. And it actually is less typing and less things we have in our program, the more efficient the program is going to be anyway. So with the for each, we can't just chain in that join. We have to say our str is going to equal our str join, and that's an extra line of code that we don't want. So this map function is really useful. And plus, let's take a look at our main program right here. This is actually the function of our entire program. It looks pretty slick, and it just, I don't know, makes me feel smarter that I can just put everything in one string. All right, it makes me feel like a elite hacker. Not really, but you get the idea. It's just better. So let's go back. All right, we don't need our for each anymore. We're really taking a look at our map. Our map, again, is just going to take everything in our array, every object in our array, and apply the same function. That can be an anonymous function, which we could do, and then just add that stuff to it like we would in our for each, or we could break it out into a separate named function, which was what we're doing, because these are skills we're going to need later on as we move forward anyway. Okay, where you're referencing a function somewhere else in your program and then using it here, which is pretty important. And so I have it set up here, so our function is set. So that should be pretty good, right? So what is happening here? So we're splitting our string. Here's a sample string here. All right, we know that we want it to say freeCodeCamp when we're done. And as we split the array, we get these letters, a space, these letters, a space, these letters, and we want to transform them. So we split it, and then we map. So as we map this function Caesar, what we're actually mapping is this new array that we have just split. So now we have an array instead of a string here with an S in our 0th position, then our first position is an E, so on and so forth, all the way down the line. So the map function is going to start with this function Caesar. It's going to apply this function Caesar to wherever we are in this array. All right, and it's going to do that for every single one of these. So what are we taking in from our array that we split? Well, it's just going to be one letter. So just to clarify what's happening here, this is a letter that we're taking in. And again, this letter is just an argument that I am using. So this is an argument. It's not a variable. It's an argument. And that argument happens to be every letter or space or number or dash or whatever is going to happen to be fed into this cipher. Luckily for us here, they're only giving us capital letters, so I only really have to worry about the capital letters. Good to go. So we should be pretty well set up. We just have to figure out what we want to do. And this is not as hard as you would think, all right, because all we're doing is we're saying if it's N, go to A, if it's O, go to B, or B, go to O. So we can write out a giant if-else statement. We could even use those switch case statements for very specific letters and codes if we wanted, but there's going to be an even easier way. Notice since these are split by 13, okay, if we have something at the bottom here, all we have to do is subtract, let's say Z here is 90, all right? If we're subtracting 13 from 90, all right, we're getting 77, and we get M. Is that what we want? Let's take a look at here. If we go to Z, we want to get to M. We subtract 13. If we want to go from Y and we get to L, all right, so let's go to Y. Here's Y, 89, and we want to get to L. What are we doing? Hey, look, we're subtracting 13. All of that stuff works really well. So let's just start off with that. So if we have something that is, let's start at N. All right, so we want to go to N, front to A. We're going to subtract 13. So if it's N through Z, subtract 13. Okay, how do we do that? So we can just say simply, we can use an if statement. So if, if what? How do we get the code of that letter? So we're actually going to have to declare a variable, huh? Yes, we are. So why don't we just call this variable the code for the chart code. So I'll call it a code. And that's going to be equal to this letter transformed into a number. Now, this letter is an argument. That argument comes from every single object in our array that we created from this string. So that code is going to be the argument letter, and not just that argument letter that is a letter, but I want to say is I want to find out what is the character or ASCII code that is a 0. Yes, I do realize that. Our char code at, okay, and it's just going to be that 0th position of that array. All right, it's basically that char code at 0 because it's that first instance. So if we do that, all right, because we only have one letter, we can just say char code. We don't have to say char code 0. We can just say char code because why? Because there's only one thing that we're looking at there. So we can just say char code add, and it'll still be fine as well. They both work. All right. I verified this previously, just so you know. So there we go. So now we have a variable code. That variable code is derived from this argument letter. That argument letter is the mapped the every single instance from this split string here that is now a position, that is now an array. So it's the every single letter here that is now in an array. That letter, now we're taking the char code of that letter and we're making that number now a variable. So what is, so let's take a look at S. The first case here is S. That S, that's going to come in as a letter. Now I'm going to take that letter, I'm going to make it a variable code, and that's going to be the char code of that letter S. So where is capital S? Capital S here should be 83. It is. And we're going to be doing something to it. And that S we want to, what do we want to do? We want to subtract 13 and make it an F. Okay, hopefully you're following me here. So let's take a look at the won't start with the bottom half because that's what I started explaining already. So let's just say if code is greater than or equal to 78 and code is less than or equal to 77. Less than or equal to 77. What am I saying? What is 78 and 77? No, that's wrong. 78 and where's Z? Z is 90. Z is 90. Sorry about that. Z is 90. 90. So if it's between 78 and 90, subtract 13 to go up. All right, so how do we say subtract 13? So if this, and again, let's forget our braces here because we're actually creating, so we can do the if statement correctly. What we want to do, we want to take code, and we want to say code minus equals 13. And remember, that is the shorthand for code equals code minus 13. Remember to end our sentence there. All right, so now, if we did this somewhat right, we should have all of our letters, all of our N through Z should now go to, N should go to A, so on and so forth. And that S should be an F. So let's test this out and just take a look at the first letter here just to confirm and see what we get. All right. And when we test it, we're not getting anything because I have not finished this up. Nope, because I didn't return anything out of there. All right. Since we're inside of a function, you remember in order to get out of a function, you have to return out of the function. So it would help after my if statement if I remembered to return ahead of myself. I have everything is now just numbers, right? I have code set to a number, and I want to take that number and I want to remember, all right, to turn that back into a letter. So how do I do that? And here is where they gave us string.charcode at. So you can take your string here, which we have, and say string.charcode at and give it a number. All right, and that number, let's see if where's the example down here? There's lots of examples. So string, where are we at here? There we are. String dot from charcode. There we go. String dot from charcode 65, 66, 67. If I say 65, it's going to give us A, 66, it'll give us B, 67, it'll give us C. Okay. So here we go. So return string from char code. All right, from char code. And what do we want to return? We want to return that char code, that is that variable we defined as code. So if we return that, let's see what happens here. That's what I want. All right. So notice that we get F from that S. Now E, we didn't do anything with the E because the E is at the top of the alphabet here, and that stuff we have to add 13 to, which we didn't even do yet. All right. And then RR, we subtracted 13 to get 2 E's. All right, the R goes to E's. All right, we're on the right track. So we've taken our charcode at, hopefully I'm clicking on the right tab as I'm explaining this. Charcode at. All right, so here's our charcode at. So if we used 0, it would return 65 for A. Since I only have one thing in that array, I don't have to worry about that 0 with position, because at that point, there's only one thing in that array. All right, so we're getting a number into our code, and then we're saying if it's in that range, minus 13, and then make sure we return at the end of our function that code. All right, and all of that is happening. This entire function here is outside of our main program. Our main program is only taking our main argument which is a string, splitting it up and applying or mapping the function Caesar to every single letter in our new array before we join it back together into a string. Okay, so all of this here is this Caesar. All right, good. However, there is one issue. We've only done half of the cipher. How about we do the other half? How do we do that? Well, we can just say else if. All right, what's our else if going to look like? Our else if is going to be the top of this, which is our A through M, which are going to be our numbers 65 through 77. 65 through 77. So if it's 65 through 77, means the code is greater than or equal to 65 and code is less than or equal to, that's not less than or equal to. If our code is less than or equal to 77, which is our A through M. Hey, don't do that. A through M. Okay. What do we want to do? We want to add 13. So we can say code plus equals 13. Okay. All right. So we have code. If the code is greater than or equal to 65 and the code is less than or equal to 77, we're going to add 13 to it. So we're only really taking a look at the capital letters here. That's the only instances we have. Those are the only things we're taking in. If there's lowercase letters in here or numbers, it's just going to pass it right back through. All right, so our map function is just going to look at it and say, okay, it's not a capital A through M. It's not a capital A through M actually here. It's not a capital N through Z here, so don't do anything with it. Luckily for us, we don't have to worry about any of those cases here, so we don't have to really worry about it. And then we remembered to return it this time, which is good to go. So we can return. All right, it likes us. So there you go. So we've taken a look at string from charcode, where you're taking numbers and making them letters. We're looking at charcode at, where you're looking at letters and making those numbers. Did I say that right? I don't even know. Letters to numbers, numbers to letters. Map, which we're taking every object in an array, applying a function to it, and because this map it creates a new array. Okay, it doesn't just transform things that are objects that are in the array there. It creates a new array. We can actually join right to that, and then just return it. And again, focusing on our main program structure here. There's our main program running, which is just this, and this function Caesar, all right, is right here. And so we can break that out later on in our program, and it is smart enough to know when it sees Caesar, find Caesar somewhere else in our code. And really, that's the that's sort of the coding, the workthrough that we want to, or the workflow that we're going to be using moving forward with some of our larger projects. So what I challenge you to do is, how can we modify this to also account for those lowercase letters? All right, and it might have something to do with if you remember how to do the or and or. All right, so take a look at that as well, because that's something else you might want to look at if you want to account for the lowercase letters. So that's the solution I came up with. There's another way to do it. You can separate these out and trying to use regular expressions as well. But the regular expressions for me don't seem to read as easy as simple ASCII codes. So hopefully that's helpful. So remember, try to take care of the uppercase letters first, and try to challenge yourself and see if you can get the lowercase letters in there as well by, again, the same method of adding or subtracting 13. Or if you really want to get fancy, take a look at the regular expressions that I showed you earlier, and there are samples of that online as well too, so if you find that. So hopefully that was helpful, and I will see you next time.